Okay, Mr. Hunt here. I'm working through the quadrilateral properties summary chart. Now, first of all, it's not really possible in this app for me to show everything, the whole table at once, so you can look on Canvas. I have the key on there. But if you want to hear me talk through it and show you my thinking and everything on this, this is a good tool to watch this video. Okay, first of all, I'm going to work horizontally. So I'm going to look at number 1, opposite sides parallel. And then I'm going to go through which shapes that's true for. You can work vertically. Okay, so you look at parallelogram and see if it's true for each one. The reason I work horizontally, though, is because go to the front page, not number, no, page 1, but the very front page, our hierarchy chart. If it's true for some of these shapes, it's true for others. So for example here, both pairs of opposite sides parallel. That's the basic definition of a parallelogram. Okay, so it should be parallelogram. Now, if you look at the hierarchy chart, a rectangle and a rhombus and a square are also parallelograms, right? So basically my point is if I mark parallelogram that is true for this property, I have to mark it for rectangle, rhombus, and square. Okay, that's the only one for those 4 are the only ones for number 1. Trapezoid, only one set of parallel sides, kite 0. Number 2, well, there we go. Exactly one pair of opposite sides parallel. Exactly one pair. So that's going to be both the trapezoids. The general trapezoid and then an isosceles trapezoid. By the way, too, I didn't say this, you can sketch, right? I put up there a sketch, so you know, like on the last one, it might help if you'd already drawn in, here's an isosceles trapezoid. Then you already saw, one pair of parallel sides, and you put the congruent marks on there. Number 3, both pairs of opposite sides congruent. This is another parallelogram property, opposite sides congruent. So it's also true for rectangle, rhombus, and square. I'm just going to abbreviate a little bit like that from now on. Number 4, only one pair of opposite sides congruent. Parallelogram has 2. So exactly one pair. So it's not true for parallelogram. So it's not going to be true for the other 3. Kite, no. Trapezoid in general, no. But the one I drew up here, yes. So this is only isosceles trapezoid. Exactly one pair, or only one pair of congruent sides. Okay, number 5, exactly 2 pairs of consecutive, also known as adjacent sides. Okay, so if you want consecutive, another word for that would be adjacent. So we're exactly 2 pairs of consecutive sides congruent. That's kind of the basic definition of a kite. It is. All right, you're drawing for a kite. Basic definition of a kite is that 2 sets of adjacent congruent sides. Yes, then you could have drawn in the diagonals or perpendicular and some other things. 6, all 4 sides congruent. That's the basic property for the basic definition of a rhombus. And here's where we go to our hierarchy chart. A lot of you might have said square. No, rhombus, basic definition, all 4 sides congruent. And if it's true for a rhombus, it's also true for a square. 7, both pairs of opposite angles congruent. So we're on to some angle ones now. The ones so far have been about sides. This is a parallelogram property, so parallelogram, rectangle, rhombus, square. Number 8, both pairs of base angles congruent. Now, when they talk about base angles, you're automatically thinking of the trapezoids, and this is only true for the isosceles trapezoid. It has 2 congruent sides, so it has these angles, and actually, these are congruent as well, both pairs. So this is number 8, isosceles, isotrap. Okay, number 9, consecutive angles supplementary. That was basic property for parallelogram. Any 2 adjacent angles, so like this one and this one, adjacent or consecutive. Because these are parallel, these are same side interior angles. And so this is a parallelogram property. So parallelogram, rectangle, rhombus, and square. Again, because those other three are types of parallelograms. Number 10, all four angles congruent. Now some of you are probably writing square right away, yes, but that is the basic definition of a rectangle. And then a square is a type of rectangle. Four right angles, that's the same thing, just worded a different way. So it's the same as number 10. Both diagonals are angle bisectors. This was not the definition, but it was a property of rhombi, that both of these, here's our drawing like this, 1, 2, 1, 2. So each of those diagonals cuts an angle, each of those angles in half. So this is a rhombus property, and if it's true for a rhombus, it's also true for a square. So we know if you draw on the diagonals here, it cuts that, well, square at 90, right? It cuts them into 45, 45, 90, something we already knew from our right triangles unit. A couple more, 13 diagonals. I like all these diagonal ones. Diagonals bisect each other. So they're not saying they're equal in length or anything about the angles. It's just the diagonals cut each other in half. That was a basic parallelogram property. So I can write it for those four. 14, diagonals are congruent. Now this was not the definition, but it was a property of rectangles. I mean, think about it. It's four right angles like that, then when I draw on these diagonals, they're going to be the same length. If you think about it for a parallelogram, I mean, or a rhombus, they look kind of like this. Certainly those diagonals are not the same length. Pictures can help you. That's why I like drawing those. So this is a rectangle, and since it's true for a rectangle, you also write it's true for a square. Okay, diagonals are congruent. So, wait, that was 14. 15, okay, just making sure. Diagonals are perpendicular. So they intersect to make right angles. This is a good one. Several shapes have this. The first one was a rhombus. The rhombus had this. It was one of the properties. They're angle bisectors and they're perpendicular. And since it's true for a rhombus, it's also true for a square. There's one more though. Kite also had this property. Like this. So when you draw those in, yeah, they make four right angles. Okay. Last one, median parallel to bases. Again, bases means trapezoids. And it's half the sum. This is that property similar to the triangle one. And it's true for all trapezoids. So it's trapezoid and then isotrap is a specific type. It's also true for that. Sounds good. All right, Mr. Hunt went through the quadrilateral property summary chart. Thanks for watching.